All right, guys, so last week we started talking about one of the states of matter, which were solids, and this week we get to talk about liquids and gases. So a solid, a liquid, and a gas are all states that matter can be in. Remember that matter is anything that has mass and takes up space, okay? So even though we can't see it, air takes up space, right? Solids take up space. Any solid can take up space in this world, okay? Even a liquid could also take up space. So we're going to look at liquids in a little bit more depth right now, and then we'll talk about gases, okay? So I have here some water that I dyed this greenish color, okay, which is some food coloring. So if you notice, the water doesn't really have a shape on its own. It has to take the shape of its container, okay? So this container just happens to be this glass cup, okay? So whatever shape the glass cup is in, that's the shape the water is gonna be in, okay? If I poured this water into this container, it's going to take the shape of this little bowl, all right? So it has a new shape based on whatever container it's in. It has a different shape than it had in the cup. And if I pour it into this bigger little bowl, it's also going to take the shape of the bowl, okay? So it depends on what container it's in. That goes for liquids and gases. That whatever container it's in, that's the shape it's going to take. It can't have a shape by itself, okay? So when I have a liquid, it flows whenever I pour it, or whenever it's, falling down in a waterfall or rushing down a river. It's flowing. So if you look, I can see right here, the water is flowing from the cup to the bowl. That's what it looks like to flow, okay? So whenever I measure liquid, just like whenever I measure solids, I talk about mass. Whenever I measure liquid, I'm going to talk about volume. So volume is talking about the amount of space that it takes up, whereas mass is the amount of matter that it contains. So I can measure volume in milliliters or ounces, and that's why little like medicine containers like this work. That's why we have measuring cups like this that tell us a little bit more about that. Okay, so we're going to look right here. Also, I wore this tie-dye shirt because it looks like liquidy tie-dye flowing all over the shirt. So fun. Okay, so if I pour this into this container, let me move this up a little bit. If I pour it into this container, I can see what the volume is. So I'm going to pour it in, and I see that it's even with right here, which is equal to 6 ounces. I could also spin it around to the other side and see that it's even, it's a little bit, but it's almost 200 milliliters, but not quite. Okay, so that is how I measure the volume of the liquid. And we get to take advantage of the fact that liquid does take the shape of its container, and that's why I can use a container like this or a little medicine thing like this to measure the volume of the liquid. And that only works because of the fact that liquid takes the shape of its container. If I were to pour it on this plate right here, it can't make a shape, okay? It's making the shape of the plate right here, but if I just pour water out, it doesn't get to make a shape because it's not in a container, okay? But in this case, it can a little bit because it's taking the shape of this middle part of the plate, but liquids just flow and spread if they don't have a container to be in. We see lots of examples of liquids in real life, okay? We see liquids in rivers and lakes and ponds and oceans, and we can see examples of it flowing from one to another really well in a waterfall, okay? So we can see how the water flows down, and then it will take the shape of its container in the lake or pond or whatever it's flowing down into, okay? Gases, all right? Gases are very similar. They're going to take the shape of whatever container that they're in. Most gases we can't see. We can see whenever water turns to water vapor, like when you're boiling a pot of water for pasta, we can see like how the air rises up, right? The steam rises up from the pot. So I just took this Ziploc bag and I blew some air into it. And you can see that it's taking the shape of the bag, right? If I blew a little bit more in there, let's see if I can. It can get really big. You close it really fast. Okay, it can get bigger. So we also know that even though air feels like it's weightless, like it doesn't have any weight or mass whatsoever, I know that anything that is matter has mass and takes up space. So if I put this on a balance with an empty Ziploc bag, it's going to have more mass on this side because this has more matter. It has the air in it, whereas an empty Ziploc wouldn't have the air in it, okay? So that is gas. So gas, even if we can't see it, doesn't mean it's not matter and doesn't take up space, okay? We get to talk later next week about how matter can change from liquid to gas, or from gas to liquid, or from liquid to solid, or from solid to liquid, because it can change depending on if I add heat to it, if I crush it, you know, different things can happen in order for that to happen, but we'll explore that more. All right, guys, thanks for watching.